Welcome, everybody, to Taking the Fear Out of Fractions with RightStart Fractions. This is part one of a three-part series. This first one here, we're going to talk about fractions in general. Part two, we're going to talk about adding and multiplying fractions. And part three is going to be dividing fractions. So let's go ahead and get started again. I'm Kathleen Lawler, and we're going to base this on the work. This is based on the work of Dr. Cotter. Webinar information, the sound is muted, so if you have any questions, please use the chat box. Thank you. I'm going to turn my video off here. There we go. So we can focus on the screen. All right, here I've got a cartoon with the peanuts. We've got the little guy saying, now we can cut an apple in half, and we have two halves, don't we? Now, and little girls saying, that's fractions, you're trying to teach me fractions, you know I'll never understand fractions. This is how most people feel about fractions. I actually have a friend of mine that went to a very good school, but she swears that they never taught her fractions in school. They did. She just doesn't remember. She was so traumatized by it or didn't understand it. Okay, so let's look at this. First of all, let's look at some of the problems while teaching fractions. A common meaning of fractions is it's a small amount. It's introduced as a part of a whole, not the whole thing. Another problem with teaching fractions is it uses ordinal words like third, fourth, fifth, sixth. So we got a different feel to it. Are improper fractions somehow undesirable? Our culture often tells us that, oh, fractions are really, really hard. They're not. And many adults only have a partial understanding of fractions. So we've got some major things stacked up against fractions. So let's start out by talking about how fractions are usually taught. So this is actually an example of fractions being taught. This was actually pulled out of a classroom textbook. We call this the fish tank model. Needless to say, they don't call it that, but this is what we call it. But the text says, what fraction of the fish are blue? So the children are to count the blue fish, and then they're count all the fish. And somehow from this exercise, we're supposed to understand that 2/5 is a number, when in fact, all we did was count fishies. It doesn't make any sense. This is not telling us what a fraction is. Here's another one. We call this the words model. Here it says this is fourths. It says this is thirds. Okay, but if this is chocolate, do you want a fourth or a third? Well, yeah, I'm taking a fourth. The words model isn't helping us. It's not helping me relate fourths and thirds. Most of us are familiar with the circles model. Try to compare 4/5 and 5/6 with this model. It's really difficult. Also, too, some kids may ask, are we comparing angles, arcs, or area? And I have to say, when I looked at this, I thought, I'm not sure. Experts in visual literacy say that comparing quantities in a pie chart is difficult because most people think in a line. And it's easier to compare along a straight line than it is to compare pie slices. These are the experts saying this. They also suggest refraining from using more than one pie chart for comparison. So this is kind of tossing out our circles. So how should we teach fractions? Well, we propose a linear chart. Here I have 1 broken into 2 equal pieces, broken into 3 equal pieces, 4 equal pieces, 5, 6, 7s. Who uses the 7s? Well, if you don't have the 7s in there, you can't see the pattern going all the way down. So use a linear chart. Now, some people say, okay, super, we'll use a linear chart, but we should really color it. Well, let me back up a minute here with this. Notice that I have an arch. See this arch that kind of comes up here? I've got it again down here. I can see that I've got line, space, line, space, line, space, line, space. I've got all these patterns in here. But if I color it, boy, seeing that arch is almost impossible. And you might have some kids who are very color sensitive and are going to say, there's no way that 3 orange 1/6 are going to be the same thing as 2 green 1/4. So we want to be careful not to color them. We want to leave it uncolored. Sometimes people say, well, we don't need the 7s and the 9s. Let's get rid of those and let's put on 12s because those are really useful. Well, look what happens. We've got line, space, line, space. Oh, apparently there's no odd number fractions. Remember that arch? We've got the first one here, but look at the second one that's down. Oh, it's gone. You can't see it down here. You've interrupted the pattern. So don't give the children missing parts. Give them the whole, including the 7s and the 9s, so that we can see all those beautiful patterns that are happening within our fractions. Ask the children to take it apart and put it back together again like a puzzle. We recommend you keep one chart intact, so you leave it together, and you have a second one where they cut it apart so they can take it apart and put it back together again like a puzzle. So let's do that here. We've got 1, 2 halves, 3/3, 4/4. By the way, notice I said fourths, not quarters, because again, we have a pattern. We have 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, and keep going. But if I were to call the fourths quarters, it's going to read like this: 1/2, 1/3, 1/4, 1/5, 1/6. There's no pattern, but there is a pattern if you use the right word. So call it 1/4 during fraction time. Now, of course, it's also another name for it is quarter, which is why we have 4 quarters in $1, 4 quarts in a gallon, but its math name is 1/4. So again, we have 4th, 5th, 6th, 7th, 8th, 9th, and 10th. Have the kids play around with them. Here's an interesting pattern where I've got 1/2, 2/3, 3/4, 4/5, 5/6. We've got this curve. Again, have the children play around with it and build the fraction stairs. Here I've got 1.5, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, and 10th. Can you imagine what 1/11th would look like, and 1/12th, and 1/13th? Yeah, you can, because again, you see the pattern. This curve is a hyperbola. Now, some of you are going, it's a what-a-la? It's a hyperbola. It's a higher level math thing, but it's interesting how the fraction chart has that. Here's the fraction stairs centered, and now we have 2 hyperbolas. So let's look at what is the definition of a fraction. A fraction is part of a set or part of a whole. That's the textbook definition. But is that really the definition that we want to use? It's part of a set or part of a whole? What about 3 halves? Because that's a whole and then some more. So this textbook definition is not correct. The American Heritage Dictionary says it's an expression that indicates the quotient of 2 quantities. Okay, that's accurate, not very helpful, but it's accurate. A mathematical definition is that it's a number in the form of a over b, where b does not equal 0. Again, accurate, not very helpful. So let's look at what exactly it means. So let's look at naming fractions. So up until now, 1 was considered the smallest unit, and fraction means to fracture, to break, to divide. So we're going to fracture our 1 we're going to break it, but it's always going to be into equal pieces. So I'm going to start out with my 1, my whole. So I have 1. I'm going to divide it into 3 equal parts. So this is 1 divided by 3, which gives us 1/3. And here I've marked my pieces, my 1/3. We read it as 1/3. And like we talked about, we use the ordinal numbers to name the fractions with the exception of half. So we've learned this. How should we practice what we've learned? Well, again, our culture and most people traditionally say, oh, worksheets. Well, how about instead of worksheets, we play games? Games are to math like books are to reading. Games help provide the interesting repetition that's needed for those automatic responses, and it provides an application for what the children are learning, just like books do. When you're learning how to read, do you do worksheets? No, you read books, preferably interesting books. You explore it. My grandson is just learning how to read, and he likes to take words and move them around and create sentences. It's providing him the repetition as he's reading and an application for the new information that he's learned. So we're going to do the same thing with games. So the first game we're going to play is Unit Fraction War. Our purpose is to practice naming and comparing unit fractions. A unit fraction is going to be like 1/3, 1/4, 1/5. And we help the children realize that a unit fraction decreases, so it gets smaller, as the denominator, the bottom number, increases. And our goal is to collect all or most of the cards by comparing the fractions. So it's a war game. It's a traditional war game. We're going to use the fraction chart as our reference. So we've got two players here. One lays down 1/4, one lays down 1/5. Whose is bigger? Check with the chart if you're not certain. Here's 1/4, here's 1/5. Oh yeah, 1/4 is bigger. So that person takes it. And now we have 1/8 and 1/2. How often have your kids told you, oh, 1/8 is bigger because 8's bigger than 2? Well, not in this case. Remember, we're taking 1 and breaking it into 8 little pieces. Oh, yes, of course, that would be smaller. So the 1/2 is bigger. Oh, now we have a war. Lay down one card. And which is bigger, 1/3 or 1/4? Again, use the chart when necessary. Your children will not go off to college with a chart tucked under their arm, but they'll get this image in their mind. And that's where we want them. So they don't have to think, okay, what's the rule, 1/3, 1/4? No, they can think in their mind, I've got 1 broken into 3 equal pieces. There's 1/3. 1 broken into 4 equal pieces. Yep, 4. Okay, 1/3 would be bigger. So we want the kids to play this game. It's a worksheet. They'll play it for hours to the point that you will cheat to lose to get out of there, which is bad parenting, but it happens. But play the games. This is the worksheet. This is the review. And most importantly, this is an application for what they're learning. All right, so let's take our chart and let's start to work with it. How many fourths are in a whole? Well, I can count them if necessary. 1, 2, 3, 4. Oh, that was easy. How many sixths are in a whole? Again, that'd be 6. I've actually met people that don't know how many eighths are in a whole. Again, with the chart, I can quickly see there would be 8 of them. So again, we're going to play a game to practice with this. So concentrating on one, it's a concentration game. And our purpose is to help our children realize that 5/5, 8/8, and so forth make a whole. And our goal is to find the 2 cards to make the whole. So this is a pre-selected group that I have here. I'm going to use my chart. So if I turn over 3/5, what do I need to make 1? Well, let's go to our chart. 3/5 needs what to make 1? 2 more fifths. Have your child announce what they're looking for. I'm looking for a 2/5. And, ooh, I found it. Yay me. Okay, I get another turn. 3/8. 3/8 needs what? Go to my chart. 3/8 needs 5 more eighths to make a whole. So I'm looking for a 5/8. Oh, I didn't get it. Now, you do want your child to announce what they're looking for. 1, because it helps them retain it. And number 2, some of your kids are bright enough that they're going to turn over a card like 7/8 and kind of look at you and go, huh? Did I win? They have no idea. They're just waiting for you to go, yay, or oh, shoot. So have them announce, I'm looking for a 5/8. Turn over the 7/8. Oh, I didn't get it. Now it's your turn. You choose a 5/8. 5/8 needs what to make 1? Ooh, 3/8. Have you been paying attention? Do you know where it is? Yes. And the game continues from here. Now, I'm going to back up a minute here. Notice when we're doing this, we didn't tell the kids, well, it's 5/8, so 5 minus 8, or 8 minus 5 is 3, so the answer is 3/8. We're not giving them an algorithm. We're not telling them, here's the formula. We're having them explore it, and it's hands-on. We let them figure out that 5 and 3 more which is my 3/8, is going to give me the whole. So you're not telling them how to figure it out. They're using the chart to figure it out. All right, let's look at some more fraction naming. So here, we've already talked about this. Or actually, I take it back. Sorry, I went two different directions here. This we would call 2 1/3. We write it as 2/3. Okay, that's really easy. I can see I have 2 1/3. That's the same thing as 2/3. Now, remember when we did this, 1 divided by 3 gave us the 1/3. We can do the same thing, and we're going to do it this way. We're going to say 2 divided by, so I have 2 divided by, or divided into, 3 equal pieces. So it's 2 divided by 3, which is this amount, which is the same thing as what we had before when we said it was 2 1/3. So there's 2 ways to look at this. 2 divided by 3 is the same thing as 2 1/3. Now, some of you are going to struggle with this. I have to confess, this took me a couple years to really get this idea. So if you didn't get it right away, don't worry about it. It's a process. It's another way of looking at something you're familiar with. And if you can look at something more than one way, you're going to have a much better understanding of it. All right, let's begin to compare fractions. What's more, 3/4 or 4/5? Don't look in your head, look in the chart. 3/4, 4/5. Oh, well, yeah, of course there'd be 4/5 bigger. 4/5 is bigger. Let's do another one. What's more, 7/8 or 8/9? 7/8 or 8/9? Ooh, 8/9 is just by a little bit. Again, see how simple this chart makes it. But let's go back to our circles. What's more, 4/5 or 5/6? I have no idea. I really don't like pie charts. It's pie. Let's just eat it. It doesn't make any sense. It's very difficult to do it. The chart is so much easier. All right, I'm going to do something with the chart, because remember I said you keep one intact and one you cut apart. So I'm going to take my pieces, and I've got my 1s, halves, fourths, and eighths. Now I'm going to do something here on the computer screen that you can't do in real life, but I got to show you because this is just awesome. So I'm going to take this, and I'm going to erase my horizontal lines. I'm going to get rid of my little green numbers. What does that look like? It's a ruler. I have had people be absolutely flabbergasted when they realize that fractions and rulers are related. So let's practice this newfound concept by playing a game. So again, it's a war game. We're going to use our 1s, halves, fourths, and eighths, again, to help us practice with a ruler. And because it's a war game, we're trying to capture all the cards. Side note, for those of you that have very competitive children or children who do not deal well with not winning, maybe only play the game for a length of time rather than capturing all the cards. So maybe you play the game for 10 minutes or 20 minutes. That way you don't have one child as a loser. Again, you know what's best with your children. So here I've got my chart, my 2 cards. Now this first one is going to be super easy because we've been playing this. We know which is bigger, 1/8 or 1/4. But again, if I need to, I can check my chart. 1/8, 1/4. Oh yeah, 1/4 is bigger. I knew that. Okay, this is going to be tough. 5/8 or 3/4. Let's go to our chart. 5/8, 3/4. Oh, 3/4 is bigger. See how easy that chart makes it. Another war. And now who takes it? Again, go to the chart. 3/8 or 1/4. It's going to be the 3/8. And when we get really good at that, we can do an advanced fraction war. So we do things like, what's more, 4/7 or 5/9? And which is bigger? It'd actually be the 4/7. All right, let's move into equivalent fractions. How many fourths equal a half? How many fourths equal a half? It'd be 2/4. How many eighths equal a half? Be 4/8. How many sevenths equal a half? There'd be 3.5 of them. Now, some of you said, ooh, can't do that. Of course you can. There's 3.5 of them. It's right there. We can see it. We don't normally call it 3.5 sevenths, but there's no law that says you can't call it, you can't have 3.5 sevenths because it's right there. I can see it. 3.5 sevenths. So let's take our fraction chart. Actually, sorry. I was thinking we were going a little bit farther with this presentation, but again, we're going to be dealing with part 2 and part 3 coming up. And then we're going to deal with simplifying fractions, adding, multiplying, and dividing fractions in the next parts coming up. So what we want to do with the fraction chart is we want to allow the student to explore the whole picture and the relationships within the whole using the linear perspective. The RightStart Math program does teach fractions all the way through A through F. There's more focus in levels D and F, and there is a carve-out available with the RightStart Fractions book, where you can learn fractions in 42.5 days. We have it available as a kit. You're going to be practicing what you've learned in this particular kit, playing with your card games, and the fraction chart does come with that kit. The RightStart program has received numerous awards. The most recent one that we got is the Practical Homeschooling Readers Award in 2017. We've been #1 for quite a few years here, as you can see. So in conclusion, math needs to be taught so 95% is understood and only 5% memorized. The children need to see it and experience it and work with it and play with it. Our goal as teachers of mathematics is to help our children transform, expand, and refine these beginning ideas into deeper mathematical thinking. Does anybody have any questions? Does anybody have any questions that I can help anybody with? You can write them right in the chat box, or you can also give us a call at 888-272-3291. You can also write to us at info@rightstartmath.com. And of course, you can also go to our website, which is rightstartmath.com.